Well, now we're going to really start to explore the spatial part of Postgres with PostGIS. Now, in reality, we've already been doing it, right? Every now and then we just throw in a little spatial command. That was just to give you a general idea, but I want to take a little deeper dive into it. And really, we want to look at some simple examples that illustrate SQL constructs within a spatial paradigm, and then to combine them with traditional SQL. And again, I want you to remember, like we've been talking about, geometry is just another data type. So we can start to treat it that way, and I think that gives us a lot more leverage. I've got two links here. We can look at each of them. The first is the link to the PostGIS Developer's Manual, and you can read all kinds of things about it. And you can see it's very long, it's very comprehensive. But what we're going to do is we're going to focus mostly on Chapter 8, the PostGIS reference. So here's where we're going to look at a lot of different kinds of functions that we're going to use in PostGIS. So for example, here st make box, so it makes a two-dimensional box. Make an envelope, so create a rectangular polygon around different objects. Here st point, we're going to make points as well. So we can look down through a few others. And here's some more ones that you might be familiar with from as a GIS professional, creating centroids for data. The contains clause, remember we looked at that earlier when we were running some of these queries. So all kinds of different topological considerations. If I just click on this, it will describe what stcontains does. It returns a Boolean, meaning it's true or false. One object does or does not contain another object. And then you can see more of the description, and the PostGIS manual has lots of great examples of what is considered a containment and what might not be considered a containment. And then finally, they will give a few different examples. And again, there'll be other types of commands that they think are similar to the one you were just looking at to help you along the way. So we're better to start with the letter A. So let's look at how to create adjacency issues or adjacency considerations in Postgres with PostGIS. Now adjacency just means are two objects next to one another. And for PostGIS they use st touches. So when we look in our help under st touches, what we can see is it returns true only if only points common between the two geometries lie at the union of the boundary. And as we scroll down, you can see these are the examples. So notice they're not intersecting, they're not covering one another. They're actually just touching, or they're sharing some part of a boundary. Well, back here in QGIS, let's right click on Query Result, and we'll update the SQL layer. So what I want to do next is let's grab our query. I'll copy that, and then we'll paste it in here. And I'm going to tidy this up a little bit, because this is, now we're getting into a little more complicated issues here. We're doing some nested select statements. So I'm interested in knowing what properties are adjacent to this particular property. Parcel key 507.006 and so on. In fact, what we can do is just let's find this particular one. We'll execute it. That's done. And then let's update it. And we come back into QGIS. And let's zoom to the area. So here is our particular parcel, and that matched the query. So what I want to do now is select. So now I've selected that, and it's almost like this is its own table, isn't it? So this is a nested select. I want to select star from TC parcel, in other words, get all the parcels, where the parcels geometry, all the 35,000 or so parcels, where they touch just this particular geometry. So let's execute that, and then we see a couple other ones are selected, and let's hit update. And now you see the properties that are actually touching or adjacent to the parcel that we're interested in. You could almost think of this as an abutters notification. So maybe instead of selecting star, maybe we select mailing. And then we can execute that. So now what we have is a mailing list. Well, that's just the name. So let's go back. And here we can select the mail underscore 1 ADDR, and then we can use the two pipes, space, and then mail underscore city, the two pipes, quote with a space, again two pipes, and then mail underscore state. And I don't want to take a whole lot of time here, so we'll just leave it at that. Let's execute this. So now what I have is the actual mailing addresses for the properties that were adjacent to the one we were looking at. So here we're using a spatial construct, but we're also combining it with traditional SQL, and there's another way we can do that as well. What if we want to be interested in the sum of the assessment values? In fact, I'm not even going to bother copying this. Let's just go back and see what we'd have to do. I can say ASMT, that's going to get me all the assessments. Let's just do it. So that's all the assessed values, but I can say sum of the assessment. There we go. And then I can say colon, colon, numeric, colon, colon, money, and then as sum ASSMT. And there it is. So that's the sum of the property assessments for all the properties that are adjacent to the particular parcel key that we passed in. The next one is buffer. So why don't we buffer that particular property? And again, what you see is this st underscore buffer again. So for spatial transform buffer. So let's create this. And I'm going to make a couple little changes here. Let's come in and put that in there. Instead of saying select star, let's just say select that as geom, because we're expecting to have a geometry column. And we can do that. Just that. So let's buffer that by 300 feet. And then let's come back into our map. And let's just kind of see this work in a live fashion. And let's zoom out. And if we just look kind of at the circle, about 300. So we're about 300 meters apart. So that did what we asked it to do. We can change this to, say, 100 meters. Let's execute it. Let's update it. And there it goes. So it's a little bit smaller. Now I wrote in here, let's do it for assessment greater than 300,000. So we can do something like let's buffer it by 50. I think that's going to be too big. Otherwise, from TC parcel. Now where ASMT is greater than, let's do 350,000. There we go. So again, we can execute that. And we'll give that a moment because buffering quite a bit. There's 5,000 of them. And then we can say update. And we'll give that a moment to complete. And that's done. And I'm not even going to bother looking at that. That's kind of a waste of a query. But you get the idea that we can perform these operations on any kind of a value. There we go. Key, and then let's execute this one more time. There we go, and let's update it. And that gets us back to normal. And in this case, we can also, again, go to the next letter in the alphabet. Let's go to C for contains. So let's see the difference between contains and touches. Before we do that, though, let's first look at our query here. How about this being one table? So select star from, and there we go. So that gives us a buffer. As T1. So that gives us the result. And we can update that, and it'll be the same value. But now I can say select TC parcel dot star from, and I can say TC parcel, comma, this, where st underscore contains t1.geom tc parcel.geom. So now what I want to do is select all the parcels that are contained in this buffer. That's done. We'll update that. And then these are the ones that are contained. So that's obviously different than touches, right? Because they don't necessarily have to share a boundary. Just one has to be contained in another one. So let's look at this query under contains and something that's maybe a little more interesting for us. And here we're going to say, let's select everything from TC parcels, from the parcels and the flood zones where the flood zone actually contains the parcel, and the flood zone is AE. So we'll run that, and we have 240 rows. We can come back to our map here, and then we'll update it. And a lot of those go away. We might have to zoom out a bit in order to see the areas that we're looking at. Yeah, and you can see a few of them right now. All right, so the next thing I wanted to do was look at the difference with TC parcel where we use ST touches. And let's just change that. Touches. Again, you get the IntelliSense, which is really nice. Execute this. And we get nothing. Any guesses why? Well, if you're thinking about what TC touches does, it's only if they share common boundaries. It's very unlikely that the flood zone boundary is going to actually be coincident with a parcel boundary, right? It's going to overlap it. So that wouldn't be a good one to use, but we could also do ST, I hate to jump ahead here, but intersects. So we'll execute that. And now we have 1,600 rows. Remember, before we had 200. Let's hit update. There we go. A lot more happened. Now, why is that? Let's even look in this particular area right over here. And if we put on our flood zones, you can see, oops, that this particular flood zone, the small skinny one, is actually the AE flood zone. I didn't quite grab that one correctly. The others represent a different flood zone. So here we go. So here's our AE flood zone. So that one actually intersects the parcels, but they didn't contain the parcels because it's not big enough. So that gives us an idea of what's the difference between containing, touching, and then intersecting. And they're going to get different results. And you should already kind of know this from other GIS work that you do, but again, it's nice to see that Postgres and PostGIS allows those same kinds of distinctions. Well, that's okay to get a map of it, but sometimes what we really just want to know is the sum of some value, like the total number, and also maybe the sum of the assessment. So let's look at this query. So again, this is the same, looking at the contains, as well as we'll look at the intersects in a moment. So here I want to sum up the parcel data for their assessments where they are contained by the AE flood zone. So if I run that, and let's execute it. There we go. And let's do this, of course. : numeric : money, and we'll execute that. All right, so $103 million. Let's change that ST contains to ST intersects. Any idea what's going to happen? Think about it. What do you think we're going to get more, or do you think we're going to get less? Well, contains is a lot more specific. I need to have the whole flood zone, the AE flood zone, actually have a parcel completely contained within it. So here we'll see where otherwise we have to just do an intersection. Well, there we go. Now we're talking about $1 billion of damage, or at least of exposure or vulnerability. And then the other thing I asked for here, let's do it with a group by statement. So we've already talked about the group by. So I've gotten my assessment. I can also get prop class. There's our prop class field, and then we type group by prop class. We'll execute that, and there it is. So now and then I can also say order by sum ASMT. So I'm going to have to call this as sum ASMT. Let's execute that. There we go. So agriculture has the least exposure, residential has the most, and here's commercial, and then community service. And again, I just ask you to pause for a second and ask, how do I do this in a traditional GIS? Remember, the question earlier that we posed is, this is so complicated, we need special consultants, it's obscure code. What has to happen? Well, again, I have to use a select by attribute command to find all the AE flood zones. Then I have to intersect those flood zones that were selected with the parcels, right? So that's a select by location. And then what I have to do is I have to then compute some kind of summary statistics for the data after I've run all those commands, and then I need to click on some kind of an order by statement. So a lot of steps in a traditional GIS. Very easy, very English-like in Spatial SQL. So let's move on to looking at distance functions, because again, one of the things that we often like to do with GIS is work with distances. But in this case, let's stop this lecture. We'll pick it up on the other side because we're kind of running long on this lecture.